In the previous video of our employee management system, we have been using commands, queries, and MediatR throughout the application. But have you ever wondered what was the actual reason behind separating commands and queries? Couldn't we simply create a single employee service and implement create, update, delete, and get operations there? After all, that seems much simpler. So, why introduce additional classes like command handlers and query handlers? That's exactly what we are going to understand in this video. We will first look at the traditional approach, then understand the problems it creates as an application grows, and finally, we will see how CQRS solves those problems using the same employee management system we have been building throughout this series. So let's get started. Before we jump into CQRS, let's first understand how this feature is typically implemented in a traditional three-tier architecture application. Here I have a sample application built using a traditional three-tier architecture. As you know, in this architecture, we have our presentation layer, business layer, and data access layer. Let's focus on the business layer. Inside the business layer, we have an employee service class. Let's open the code and see how it's implemented. Let's look at the service carefully. Here we have the methods for retrieving employees, creating employees, updating employees, and deleting employees. In fact, this is how many applications are traditionally built. For smaller applications, there is absolutely nothing wrong with this approach. Everything is available in one place, making it easy to understand and easy to get started. But now let's think about a real enterprise application. The application has been running for several years. New business requirements are added every sprint. More developers join the project, and this service keeps growing. Let's look at these two methods, get all async and get by ID async. These two methods are responsible only for reading data. They never modify anything. Now look at the create async. Unlike the get methods above, this one actually changing the data in our database. The same applies to the update async and delete async. So within this single service, we have now two completely different responsibilities. One is reading data, the other is changing data. Now imagine tomorrow the business says, when creating an employee, also sends a welcome email. Next week, publish an event, write an audit log, validate duplicate emails, notify another system. All this logic gets added to the write methods. At the same time, the read also keeps growing. Searching, phasing, filtering, reports, dashboard queries. Eventually, this one service becomes responsible for two completely different kinds of work. That's where the complexity begins. The real problem is that both read operations and write operations continue growing inside the same class. As the application becomes larger, maintaining this service becomes increasingly difficult. So instead of organizing our application around CRUD operations, what if we organized it around responsibilities? What if everything is responsible for changing data was handled in one place and everything responsible for reading data was handled somewhere else? That's exactly the idea behind CQRS. CQRS stands for Command Query Responsibility Segregation. The name sounds complicated, but the idea is actually very simple. Commands change the data, queries read the data. Before we jump into the implementation, let's first understand the overall architecture. Once this architecture is clear, the code becomes much easier to understand. Let's walk through this architecture from left to right and understand how the requests flow through the system. Everything starts when the client sends an HTTP request. The request first reaches to our controller. Now notice one important thing here. The controller does not contain any business logic. Its responsibility is only to receive the request, understand what operation is being requested, and pass that request further into the application. Instead of directly calling a service class like we typically do in a traditional three-tier architecture, the controller sends the request to the mediator. Think of Mediator as a central dispatcher. It receives the incoming request, identifies what type of operation it represents, and routes it to the appropriate handler. Now, if the request is an operation that changes the state of our application, for example, creating a new employee, updating employee details, or deleting an employee, that request becomes a command and it is processed by a command handler. But if the request is only asking for information, for example, getting employee details or retrieving a list of employees, the request becomes a query and it is processed by a query handler. This is the core idea behind CQRS. Commands are responsible for changing data, queries are responsible for reading data. They are separated because they usually have different responsibilities and different requirements. The handler contains the application specific logic required to complete that operation. When it needs to access data, it communicates with the repository. The repository takes care of interacting with the database and returning the required data. Once the operation is completed, the response flows the reverse path back to the client. Repository returns data to the handler returns the result to the mediator sends back to the controller, and finally, the controller returns the response to the client. So here, this architecture may appear to have more moving parts compared to a simple employee service class, but the difference is that every component now has a clear responsibility. Controllers handle HTTP communication, mediator handles request routing, handlers handle application logic, and repositories handle data access. This separation makes the system easier to understand, easier to test, and easier to evolve as the application grows and the business requirements become more complex. Now that we have understood the overall architecture, let's see how each of these components is actually implemented in our employee management system. As you can see here, our solution is organized into four different projects. We have the API project, the application project, the domain project, and the infrastructure project. Since CQRS is a part of our application's business logic, we will focus on the application project. Inside the application project, you will notice something different from the traditional approach. Instead of having single employee service containing all the CRUD operations, we have organized our code into two separate folders, commands and queries. This separation is the foundation of the CQRS pattern. Commands are responsible for changing data, while queries are responsible for reading data. Let's start looking at the commands folder. Think of command as a request that asks our application to change something. In this case, our request is to create a new employee. Similarly, we will have separate commands for updating an employee and deleting an employee. Each command contains only the information required to perform that specific operation. Let's open create employee command and understand how it works. This class represents our request to create a new employee. Notice that it contains only the information required for creating an employee. There is no business logic here. Now notice this interface, IRequest. So what exactly is IRequest? IRequest is an interface provided by the MediatR library. By implementing IRequest, we simply telling MediatR this object represents a request that should be processed. The generic type parameter tells MediatR what type of result we expect. In this case, we return the newly created employee object. That's why we are using employee. If nothing is needed to be written, we could use IRequest and parameter as a unit. Now let's open create employee command handler. This class implements another mediator interface, IRequestHandler. Think of it this way, the command represents the request, the handler is responsible for executing that request. Every command has its own dedicated handler. Whenever a create employee command is sent, Mediator automatically finds the handler. Now let's look inside the handle method. This is where the actual business logic is get processed. We receive the create employee command, create the employee entity, call the repository, save the employee, and return the employee. Also notice that we are depending on employee repository interface instead of DB context. The handler doesn't care whether the data is stored in SQL Server or PostgreSQL or any other database. It simply performs business logic. Now let's see who actually calls this handler. Let's open our employee controller. Notice here how simple our controller is. It doesn't contain business logic. It doesn't access the database. Its only responsibility is receiving the HTTP request and forwarding it. The important thing here is Mediator send command. When we call send, Mediator examines the request type. It recognizes the create employee command. Mediator searches for IRequestHandler, finds create employee command handler, execute handle, receives the result, and returns it back to the controller. We never initiate the handler ourselves. Everything happens through the mediator and dependency injection. Let's open program.cs and check how we have registered the dependency for this mediator. Here we have registered the mediator. During application startup, mediator scans the assembly, finds all IRequestHandler implementations, registers them automatically. That's why we don't manually register every handler. Now let's run the solution and verify everything at runtime. I will place breakpoint at our handle method and also at the repository where it is creating the employee. Now let's run the solution. Okay, so here now we can create our employee. Okay, execute this and check the flow. We come at this handle method. Let's debug the inside. We came to the repository. Inside the database, it has created record and written our employee object. It has returned back to the handle method, and this handler returned back to the our controller. Now see the response. So this is how finally the controller returns the HTTP response. Now let's look at the query inside. We will call this employee by ID and check the flow. So the request came to the controller. It has passed to the handler, and handler has passed request to the repository to get the employee from the database. Let's debug inside. It has returned the data handler, and handler returns back data to the controller. So this is how we have the response. Let's check the response, and we have this response. So let's quickly recap everything what we have learned. We started by looking at the traditional employee service. There was nothing technically wrong with that approach, but as the business requirements grow, read operations and write operations continue growing inside the same class. CQRS solves this by separating responsibilities. Commands change data, queries read data. Every request implements IRequest interface. Every request is processed by IRequestHandler interface. The controller simply sends the request. Mediator locates the correct handler. The handler executes the business logic, and the request is returned back to the controller. Before we conclude, let's clear up one common misconception. Many developer believes CQRS automatically improves application performance. That's not true. CQRS is not a performance optimization technique. Its primarily purpose is separating read responsibilities from write responsibilities. In our employee management system, both commands and queries use the same database. So CQRS itself doesn't make our application faster. However, in large enterprise applications, once reads and writes are separated, they can be optimized independently. For example, caching, RAID replicas, specialized read database, those optimization can improve performance, but they are built on top of CQRS. They are not provided by CQRS itself. I hope this video help you understand not just what CQRS is, but more importantly, why we use it in clean architecture application. Thank you so much for watching, and I will see you in the next video.